Welcome to today's session. Today we are going to see solving linear inequalities. So these are 8 topics we are going to cover in this video. Let's start. Okay, let's start with the first topic. What is a linear inequality? A linear inequality is similar to linear equation, but instead of equal symbol, we use less than or greater than or less than or equal to or greater than or equal to. These 4 symbols we are using instead of equal to. So before that, we will see an example of a linear equation. How a linear equation look like? Just assume this same linear equality, just same example we will get in a, we'll make a linear equation. So 2x plus 3 is equal to 7. Assume that this is an example of a linear equation. So here equal sign we used. Here there is a equal sign instead of this greater than sign. Here is an equal sign. So this is a linear equation. So this is a linear inequality equation. But what's the difference? Only the symbol. So how to solve a linear equation? As we already know that how to solve a linear equation. We use the algebraic tricks. How to find the value of x? So first we need to isolate x. That means we need to put x, only the x on the left hand side. Balance all the terms we need to remove. So first we will remove this plus 3. So whatever we do in the left hand side, the same thing also we need to do in the right hand side. So 2x plus 3 minus 3 on the left side. The same thing we do in the right side, 7 minus 3. 3 and minus 3 will cancel. So the left hand side, it will be 2x left. In the right hand side, 7 minus 3 is 4. There's a 2 in the left hand side with the x. So we need to isolate only the x we need on the left hand side. So what we do, we need to remove the 2. So divide 2 on both sides. What will happen? The 2 and 2 will cancel on the left hand side. And the 4 divided by 2 is 2. Value of x is 2. This is the solution of a linear equation. So if you substitute 2 in this equation, so 2 times 2 plus 3 is equal to 7. Is it true? Yes, 2 times 2 is 4. 4 plus 3, 7. Yes, correct. So this is how we solve a linear equation. The same technique, the same algebraic steps, algebraic techniques we use here to solve a linear inequality equation. So how to solve? Let's solve this linear inequality equation. So first what we need to do is just consider the equation as it is. Keep this symbol as same. As it don't change any symbol, just keep the symbol as same and find the value of x. So what our aim is to isolate the x only in the left hand side. So remove all the things on the left hand side. We need to find only the value of x. So the same technique we use here. What we do? First we will and minus 3 on the both sides. Okay. So 2x plus 3 minus 3 greater than, keep the symbol same, 7 minus 3. So both sides we subtract 3. So 3 minus 3 here cancel. 7 minus 3 here, it's 4. 4 on the left hand side. Keep the symbol same. What left in the left hand side? 2x the left hand side. So now we need to remove 2 also from the left hand side. Then only we need to isolate x. So divide by 2 on both sides. Okay. So the 2 and 2 cancel. 4 divided by 2 is 2. So the value of x is x greater than 2. So all the values greater than 2 we can substitute in this equation, will meet the equation true. So all the values above 2. That means how we plot here, but 2 is not included. Okay. So because it's a greater than symbol, so when we put a bigger circle, because the 2 is not included. So x is greater than 2. That means all the values of x, all the values greater than 2 is go up to positive infinity. So all the values above x. So all the values above 2. So in interval notation, how we will write in interval notation? 2 comma positive infinity. Open this open bracket because it's both are not included. Okay, the topic number 2. So rules for solving a linear inequalities. So there is we already discussed how to solve a linear inequality is same like a linear equation. Solving a linear equation, the same techniques we use. to solve a linear inequalities. But except there is one special rule we need to see for solving a linear inequality. What is that special rule? See, solving just like a linear equation, the same thing we use. So important rule is that if you multiply or divide, see, if you multiply or divide both sides by a negative number, we have to reverse the inequality sign. This is the only important rule we need to keep in mind while solving a linear inequality equation. Let's see an example. This is an example of a linear inequality equation. See how to solve this one. Let's solve this one. So minus 2x greater than 6. So what we do, we will just isolate the x on the left hand side. So divide both sides using what? A minus 2. What will be the left hand side? A minus 2 and minus 2 will be cancelled, and a minus 2 and 6. So minus 3 will be right hand side. So this, when we apply this rule, in this case what? We need to reverse this symbol. So the value of x is x on the left hand side, right hand side is minus 3. What about the symbol? Reverse the symbol. So greater than symbol will be a less than symbol. This is the solution of this linear inequality equation. We need to reverse the sign. So interval notation will be, it will be minus infinity, comma, minus 3. That means all the values are less than minus 3. All the values less than minus 3 till infinity. This is the interval notation. This is a solution. This is the values of x. So when we divide or multiply using a negative number, we need to reverse the symbol. Let's see and solve example with using a single inequality equation. In this example, 3x minus 5 less than 10. So this is a linear inequality equation. So how to solve this linear inequality equation? We need to find all the values of x which makes this equation true. So find the values of x. That's the main aim of solving a linear inequality equation. Find the values, find the unknown values, okay, of x. The first step is add 5 on the both sides. So how we need to isolate the x on the left hand side. So we need to remove the term, this 5 term first. So 3x minus 5 plus 5 less than 10 plus 5. So the left hand side will be minus 5, so cancel. So 3x 15. Okay, so 3x 15. The same thing, what we need to remove the 3 also, the left hand side. So divide by 3 on both sides. So what will be? So 3 and 3 cancel. 15 divided by 3 is 5. So x less than 5. All the values less than 5. So the interval notation will be x less than 5. So minus infinity, comma 5. So both are not included, 5 is not included. Okay, this is the solution. So we can see either x less than 5 or in the interval notation minus infinity to 5. That means when we see in a number line, this is 0, this is 5. So this is minus infinity and plus infinity. So the x lies between 5 and going backward. This is minus 1, minus 2. So minus x lies between 5 and minus infinity. All the values in this range. This is how we solve a linear inequality equation. Okay, let's see the next example. Here see minus 4x plus 1 greater than or equal to 9. So before it was a single inequality equation, now there is a 2 symbol. That means greater than or equal to. So let's solve this equation. The first step is, as usual, first eliminate this 1. So subtract 1 on the both sides. So minus 4x plus 1 minus 1. Symbol same as it is. 9 minus 1. So 1 minus 1 cancel. So it will be minus 4x in the left hand side, greater than or equal to 9 minus 1 is 8. So next step is we need to remove the minus 4. So we need to follow the special rule for the linear inequality. A divide of 4, divide by 4 on the both sides. Minus 4 and minus 4. So this minus 4 and minus 4 cancel. Minus 4, which is minus 2. So the answer will be, so we need to reverse this sign. So the final answer will be x less than or equal to minus 2. This is the final answer. First we see the number line. So the values of x lies between less than or equal to minus 2. So the minus 2 is included. So we will make a closed circle here. So minus 2 to minus infinity. All the values between minus infinity and the minus 2. Now write the interval notation. It will be minus infinity, comma 2, minus 2. So minus 2 is included. So we can square bracket, left side, negative infinity, always open bracket. This is how we solve a linear inequality equation. So always see, our aim is to find the values of x which we can substitute to the main original inequality equation, which makes inequality true. Then one of the most important thing is always check your answers. When you find your answers, always check your answers, is it true or not. So what we do, how we will check the answers, just substitute one or two values of x into the original equation. So let's substitute minus 3 in this original equation. For example, minus 3. So minus 4 times minus 3 plus 1 greater than or equal to 9. Is it true? So minus 4 times minus 3 is 12. 12 plus 1 is equal to 13. Is 13 is greater than or equal to 9? Is true. Greater than or equal to 9 is true. Okay, the next topic is compound inequalities. What is meant by compound inequality? A compound inequality has two inequalities joined together. We can join using a logical operator and or or. The and means conjunction, means overlapping a region, or means disjunction, means union. Going forward, you will see more examples. Okay, so what's the main idea behind that is, when we having a two separate inequalities, for example, we have x less than minus 3 and we have x greater than 3. These are two separate inequalities. So in this case, how we will combine this together? We need to combine this together and write it in a single inequality notation. So how we will combine this? So x, the actual idea behind this, the x is lies in the separate region. So in this side, what we will in interval notation will be minus infinity to minus 3. This is the interval notation of the this inequality. In this inequality, what is interval notation? X is greater than 3. That means 3 comma positive infinity. So how we will combine this? Because in this two region, the axis lies between this both the region. So we need both the region together. So in this case, we will use an union symbol. That means union means two separate region we're combining together. That the next section will go more examples. So we use a union. I mean, we use an or symbol to combine. So or symbol to combine this both region. Okay, the next topic is and conjunction. So we are going to see in detail of the compound inequalities, how to combine using an and. And means solution must satisfy both conditions at the same time. That means if there is a two separate inequality equation and we combine the both separate inequality equation using an and operation, so we need to find only the values of x which satisfy the both inequalities at the same time. I will explain it in a number line. First, this is an example of a and we combine two inequalities using an and. So the original two separate inequalities will be x is greater than minus 2. Okay. The second inequality is x is less than or equal to minus 4. So x is less than or equal to 4. These are the two original inequalities. We combine these two original two inequality equation using an and function. So let's draw a number line here. So x is greater than minus 2. X is greater than minus 2 means open circle going towards positive infinity. Second one is x is less than or equal to 4. This 4 is included, so close circle. So x is less than or equal to 4. So it's going towards the left side of minus infinity. So in these two separate inequality equation, I plot in the number line. So now how we will combine these two using and function. So and means solution must satisfy both conditions at the same time. So in these two inequality equation, which are the x values common to this both? These are the common region. In this common region, any values in this common region, if we put in same time with the both the inequality equation, the inequality equation will be true. For example, a minus 1. We substitute minus 1 on the both side. For example, minus 1. Is it true? X is greater than minus 2. So minus 1 is greater than minus 2. Yes, true. Same thing put here, minus 1. If minus 1 is less than or equal to 4, true. Okay, let's substitute this value 2. 2 is x is greater than minus 2. I mean 2 is greater than minus 2. It's true. Okay, here this 2 positive 2. This positive 2 is less than or equal to 4. It's true. So all the values we take in this common region, the both and substitute the both equation at the same time, linear inequalities will be true. When we take any values in this region and putting same time both the linear inequality equation, the linear inequality equation will be true. And operation. So using the and operation, we combine two linear inequality equation. Now you are combining these two using in a linear inequality equation. Let's combine. So we rewrite these two equation in this form. See, the x is lies between minus 2 and 4. So this region, we are taking the values of x only in this region. So we need to consider only the common area, I mean the overlapping region. That's how we combine these two linear inequality equation using an and conjunction. This means, see this equation, see minus 2 less than or less than x less than or equal to 4. That means x lies between minus 2 and 4. So what does it mean? X is greater than minus 2. Yes, x is greater than minus 2. And x is less than or equal to 4. So solution is all the numbers lies between minus 2 and 4. So interval notation will be minus 2 comma 4. This is the interval notation. Overlapping region. So this is the overlapping region, minus 2 to 4. This is how we solve two separate linear inequality equation using an and function. And function is always take the common region. That means we need to consider the values of x, only the values of x which both the linear equality can satisfy at the same time. So only the region, only this region is be considered. Okay, let's see an example here. See, here is an expression. This is a linear inequality expression. We need to solve this. So first, we need to know what is this mean by. See, 3x plus 1. There's a value of this 3x plus 1. The value of this 3x plus the entire equation 3x plus 1 is lies between 2 and 11. What are the values we can substitute to this x to make 3x plus 1 lies between 2 and 11? This is the task. So we need to find the values of x to make this original equation satisfied, true. Okay, so first what we do, we need to solve this. We need to solve this using our algebraic techniques. In the middle portion, I want only the x. So we can know the exactly which is the range of values of x. So first we are going to solve this. Total we have 3 sides. So this is one side this is 2 and this is 3 in this equation, because this is a combined form of two linear inequality. For example, the original, the separate inequality is 3x plus 1 greater than or equal to 2. The second is 3x plus 1 and less than 11. These are the two separate inequalities. These two separate inequalities, they combine using an AND function. They combined using AND function to form this equation. This is how this equation has formed. We have two options. Either we can solve this separately, or we can solve this on the same side. First, we need to remove this positive 1 from this side. So we need only 3x here. 3x plus 1 minus 1. 11 minus 1. So here also 2 minus 1. See, whatever the operation I did in this middle portion, also I did on the both two sides. Okay, so the 1 and 1 cancel. So 3x left in the middle portion. So what about the right hand side? 11 minus 1 is 10. What about the left side? 2 minus 1 is 1. So this is the stage. So in this stage also, I want, see, 3 also is left here. So I need to remove the 3 also. So what I will do to remove the 3 and make the x only remains here, divided by 3. Also do on the both sides, divided by 3. Okay, so this 3 and 3 cancelled. So the final solution will be 1 by 3 less than or equal to x less than 10 by 3. So these are the values of x we can use to this original equation. We can, this is the values of x we can use to the original equation, which makes the equation satisfied. So we can substitute also one value here. For example, 1 by 3. If you substitute 1 by 3 here, this equation will be satisfied or not. I will show you. See, 2 less than or equal to 3 by 1 by 3 plus 1 less than 11. So 3 and 3, 11. So 2 less than or equal to, well, what's left here is 1. 1 plus 1 is 2. 2 less than 11. Is it true? Yes. 2 is greater than or equal to 2. This side is true. And 2 is less than 11. This side is true. See, this is how we check our answers. Either you can solve this equation on the together on the same side. How I solve this, you see already how I solve this. We can do it on the same side, or else we can do it separately. For example, 3x plus 1 greater than or equal to 2. The same thing. Minus 1 here, minus 1 here. So 3x greater than 2 minus 1 is 1. So divided by 3 on both sides. So x greater than or equal to 1 by 3. Okay, on the other side, if you go 3x plus 1 less than 11, the same thing. 3x left behind, 11 minus 1 is 10. Then divided by 3, divided by 3. So x is then equal to 10 by 3. So this separate, this x values we got separately, and we can combine these two with an AND function. So we will have a x, the x is lies between, when we write a number line, we will have a common area. So this is, for doing separately is time consuming. So what I suggest you can do it on the same side. All the operations you are doing in the middle portion to make the x isolate, make the x remains, all the things, the same thing you need to do on the both side also. That's only a rule we need to apply. So any values between 1 by 3 and 10 by 3, you can take and substitute to the original equation. You will have the equation satisfied. So these are the solution. The x values are the solution of a linear inequality equation. Next one is OR, that is disjunction. That means union. See, what is or? Or means this, actually or is exactly the opposite of the and. See, what is and? And means the common region, the common overlapping region. But the or means the entire region, all the entire region. That's we call or. So when using an or, if you combine two separate inequality equations in an or function, that means the both the inequalities, all the values of x of the both the inequalities we can consider. Let's go to the deeper. See, just see an example here. These are the two separate inequalities, x less than minus 2 or x greater than 3. That is a two separate region. Okay, let's see in the number line. So this is a number line. This is 0, this is 3, and this is minus 2. Then the first x is less than minus 2 means from here to minus infinity going forward. So x is greater than 3 means from here to infinity. These are the two separate regions. Combining using an and, if we combine these two regions using an and means it's a null. It's a null set. Null set means there is no overlapping region. That means we cannot combine this region using two region using and function because there is no common area. So if even we combine, the values of x will be 0. There is no values because there is no common region. In this case, if we combine these two regions using an or function, means all the values, just combine all the values together. That's it. So two separate region on the number line. Say interval notation will be minus infinity to minus 2, a union a 3 to infinity. So this all the entire values in this region plus this region together. So in this case, what the definition said means, or means the solution satisfies either one condition. For example, if we minus 3 in this both cases, x is if the x is minus 3, is this condition satisfied? I mean, x is less than minus 2. Yes, this gets satisfied. What about this? If it's minus 3 here, if this inequality satisfied? No. But in this, if it's an and operation, we will not consider 3 because both the inequalities did not satisfy at the same time. But in the or case, either one of the inequality satisfied, then we can take the value. That's the difference between and or. So either any one of the inequality satisfied, then in this case, we will consider that value. That's what this means by or disjunction. There is no common overlapping, or whatever the values having in the both two inequality, just combine together. This is how we combine together. See, the two interval notation, the two inequalities, the set of values, x values of the separate two inequalities combined together using a union function. This is a union function. This is called or. This is how we combine two. We use the symbol to combine, to add, or to combine two different sets of x values. So two separate set of values together. And the symbol we use is called union. Okay, let's do some example using or operation. Okay, two separate inequality equation, and we combine these two separate inequality equation using an or function. So we already know the definition. Or function means either one inequality equation satisfied, we can consider that value. Okay, so we need to find the values of x in the both cases. In this case, we can need to solve this equation. So this is x is not isolated because x has some components also. So we need to isolate the x and find the values of x. So we need to solve this separately. So first one is x plus 2 less than or equal to minus 1. So we need to do first what? We need to remove the 2 from here. So x plus 2 minus 2 less than or equal to minus 1 minus 2. Okay. In this side, what? Okay, well, let's finish this one. So minus 2 cancel. So x remains here less than or equal to minus 1 minus 2 means minus. So minus means minus 3. Okay, so x less than or equal to minus 3 in this side. What about the right side? 2x greater than 6. So divided by 2 on both sides. So 2 cancel. This is 3. So x greater than 3. So these are the two set of x values. So in this OR case, we need to combine this together. So make it in a convert this into an interval notation. So x is less than or equal to minus 3. Minus 3 means if we look for the number line, this is 0, then this is minus 3. X is less than or equal to minus 3. That means including minus 3, we will go forwards to minus infinity. So what about this case? 0. This is 3. X is greater than 3. That means not included towards infinity. So this region and this region. So in its interval notation, it will be minus infinity, comma, minus 3, because minus 3 is included, because it's x is less than or equal to. Okay, what about the right and the second one? X is greater than 3. That means 3 is not included. So 3, comma, positive infinity. Okay, so both are from bracket. This is the two interval notation we got from the while solving separately. Now we combine this. How we combine? We combine using a union function. So union symbol. So little bit clearly we can write. So what is this mean by? That means the values of x. The values of x lies between minus infinity and minus 3, and also 3 and infinity. So these two sets, any value we put in this original equation. So any one equation satisfied, then we can consider that one. So the entire region, so the two separate region combined together, and consider all the values of x on the both separate inequalities. So with this both separate inequality, all the values of x values combined together. So it's a big set of x values. That's what OR function means. Let's go for a quick comparison between union and overlapping. It's very important. Union, the symbol is U, and the meaning is combining all solution. That's we can also say OR function. So combining all the solution. So if you have one or two or three a set of linear inequality equation, so the solve separately, then combine the final x values together. This is what a union means. Overlapping means and means a common part. So we are looking for the x values which make the both the linear inequality satisfied at the same time. That means the overlapping region, the common area, the common values of both the both the inequalities satisfy at the same time. That's called overlapping. Union means no need to satisfy the both inequalities at the same time, but at same time also is fine. But at least one inequality, the x value should satisfy with the any one of the inequalities. So that's mean by OR. So example, and is overlapping region only. OR means all the shaded parts, all the regions to combine together. This is a quick recap. So the summary. So today's summary is it's a linear inequalities. So use of less than, greater than or equal to, or less than or equal to, and what's the difference between linear inequalities and linear equation? How to solve both cases? We are using same algebraic techniques to solve it. Then next one is reversing sign. When we need to reverse the sign? When dividing and multiplying, dividing or multiplying with using a negative number. So we need to reverse the sign. So both sides, divide or multiply using a negative number, we need to reverse the sign. Next is and or. Already we discussed. And means overlap, intervals. So or means union, two regions together. So always check the number line and interval notation. So this is a tip. Always check the number line and interval notation to make sure your answer is proper and correct. And don't forget to check your answers by substituting the any one of the x values back to the original inequality equation. So that's it. See you in the next video.